Welcome to the Copper Spice YouTube channel, and thanks for joining us. In this video, we want to explore the idea of elision. Copy elision. In order to talk about copy elision, we realized it would be a good idea to start by defining the word elision. It turns out this is a fascinating topic, and the C++ Standard Committee chose the name very accurately and wisely. It may seem obvious what is meant by a copy, but do you know everywhere a copy can happen? A copy can involve more than just one operation, and this is important when you really want to understand what problem copy elision is solving. Our next step is to explore what it means when the C++ standard makes a guarantee, which every standard-compliant C++ compiler must respect. A few examples will be shown to help explain what a copy is and how this relates to copy elision.
The practice of removing sounds or letters from speech happens in most languages. When we say the word laboratory in our American accent, we are eliding the first O in the word. A person with a British accent would pronounce all the letters without any elisions and say laboratory. Eliding is typically done in a spoken language when a particular sequence of sounds is difficult to say or time-consuming. This is why it can be complicated to understand someone when they're not speaking your native language. Another common type of elision is the use of a contraction. In English, you can say either do not or don't. Both are valid. However, in formal written English, contractions are discouraged. The French phrase c'est la vie is an example of a contraction which is considered mandatory, and the non-elided form would be considered incorrect. It took a while, but we found a similar example in English. The term o'clock is actually a contraction for of the clock. If you told someone you would meet them at 2 of the clock, it is unlikely they would understand what you meant. In languages like German, compound words can be created from 2 distinct words. If the first word ends in a vowel, the vowel is often dropped when the words are combined. Most languages have similar types of rules. Elision is not a commonly used word. Most of us elide sounds when we speak and rarely even notice we are doing it. What was really funny to us is that this thing had a name. Now that we have a definition of the term elision, it is easy to reason that copy elision in C++ must involve dropping something. So the question is, what is being dropped in C++? When is this happening, and why do we care? In order to define copy elision, we need to have a solid understanding about how copies work and when they happen. Reading the C++ standard, which is not always easy, it mentions there are 2 different ways a copy can occur. One is a copy assignment, and the other is called copy initialization. We seldom talk about copy initialization, and yet we use it all the time. The term copy assignment should be familiar to most developers. It is simply a call to the operator equals method. This is what most of us mean when we say a copy is being made. Copy initialization is a combination of initialize the current variable and assign it the value of the past object. In other words, the compiler simply calls the copy constructor. In these 3 examples, for simplicity, the widget class is copyable but not movable. On the first line of each example, the variable is declared as type widget, which is done in one operation by calling the default constructor for widget. On line 2, the widget copy assignment method is called. In this example, data A now has a new value. On the second line of example 2, the first thing which must occur is that data D is default constructed. Then the widget copy assignment operator will be called to copy the value from data C to data D. It is important to observe that both a constructor and a copy assignment method are called. Here is where we start to question, are we asking the compiler to do a lot of copying? In the last example, data F is copy initialized directly from the widget in the data E object. This avoids the call to the default constructor we saw in example 2 and is potentially more efficient.
So what does it mean when the compiler makes a guarantee? Let's look at an example from C++ 11, which most programmers are familiar with, the const_expr keyword. Const_expr is typically thought of as something which happens at compile time. However, calling a const_expr function is not actually guaranteed to happen at compile time. It might still happen at runtime, and there is no way to know. The const_expr keyword is only a suggestion. In most cases, the compiler will do the right thing, as you expected. As long as the required result is produced, the standard does not actually require the operation to happen at compile time. In comparison, the const_eval keyword, which was added in C++ 20, instructs the compiler that this function must absolutely be executed at compile time. If a const_eval function cannot be evaluated at compile time, you are guaranteed by the standard to receive a compile error. As an example, this might happen if the arguments to the function are not known at compile time and instead depend on a runtime value. The idea of a guarantee is very important with copy elision, as things changed in C++ 17. Now that we have a definition of elision and when copies occur, we are ready to combine them into the term copy elision. Based on the definitions, the idea of copy elision is to elide or drop unnecessary copies, which is exactly the intent. Why do we care about this? Is a copy always something which needs to be elided? When the data is as simple or small as a bool or an int, the cost of a copy is minimal, so this really does not matter. However, doing a copy can be expensive. If the copy requires a memory allocation, like in the case of copying an std vector, then the time to do the copy can be significant. It may also be slow to copy when the object itself is quite large. Another consideration is for types like std unique pointer, which simply cannot be copied. In order to improve and optimize our code, it would be nice if the compiler would help us and avoid making a copy of our data whenever possible.
What may be surprising is that copy elision is not new, and it was something the compiler could do as far back as C++ 98. In C++ 11, the standard changed with the addition of move semantics, and copy elision was enhanced to allow both copy and move elision. So what is move elision? Similar to copy elision, it allows the compiler to omit calling a move constructor or move assignment operator when possible. It is important to emphasize that in C++ 11 and C++ 14, copy and move elision was possible and very likely to occur, but not guaranteed. The compiler could choose to elide the calls or not. Since the copy or move constructor or assignment might actually get called on some compilers, the compiler was required to verify that these methods were present. This makes sense, as you would not want your code to suddenly fail to compile if you move to a different C++ compiler. With the release of C++ 17, the standard now guarantees both copy and move elision will occur, when the conditions permit. Since all compilers are required to follow the same rules, the compiler does not need to ensure the copy or move constructor or assignment methods are valid when elision is possible. A side effect is that C++17 can take advantage of copy elision and return objects by value, even when that object is not copyable or movable.
When calling a copy constructor or the copy assignment method, it is obvious the intent is to make a copy of some data. Code that says widget A equals B has the abstraction make a copy of B and assign it to A. Even if the copy is optimized or elided, this code clearly states you want there to be two separate objects. This is how pass by value to a method or function works. Duplicate my data and pass that along. There are other places where it may not be clear that a copy is actually happening, like when a local variable appears in a throw expression. Many of these copies and moves can be elided, which is the compiler's responsibility because of the guarantee added in C++17. Keep in mind, the compiler is allowed to assume the copy and move methods have no side effects, so eliding them is fine. It is therefore extremely important to ensure that your copy and move constructors and assignment operators contain no side effects. If your program actually cares about the exact sequence of copies and moves, you may have an error in your code, and one that will be difficult to trace down. To avoid this situation, it is a good practice to use the default copy and move constructors and assignment operators. In the majority of cases, the defaulted implementation is all you need, and your code reviews will actually be a bit simpler. When you migrate to a C++17 compliant compiler, you should expect that copies and moves are elided, since this now is a guarantee by the standard. In our opinion, this changes the idea of copy and move elision from being a suggested optimization to an actual language feature.
For more information about the CopperSpice project, please visit our website at www.copperspice.com.
Thanks for joining us. We hope you found the content of value. If you have any questions or feedback, feel free to leave a comment on this video or send us an email.
Please make sure you subscribe to our YouTube channel and come back in a few weeks for our next video.